This is section 7.3, part A, hyperbolas. Your I can statements for this section. I can analyze and graph equations of hyperbolas, and I can use equations to identify types of conic sections. A hyperbola is the locus of all points in a plane such that the absolute value of the differences of the distances from the two foci is constant. The transverse axis is one of the axes of symmetry. The important thing to notice is that the transverse axis has a length of 2a units, and it connects the vertices. The conjugate axis is one of the axes of symmetry that is perpendicular to transverse, and it passes through the center, and it has a length of 2b units. Now, just like everything else we've looked at this chapter, the hyperbola has two different standard forms. We have one standard form of the equation if it opens horizontally, and we have another one if it opens vertically. Now, with the hyperbola, the a squared value does not have to be the larger of the two values. The a squared just always comes first. The difference here is that the x value will come first if it's open horizontally. The y value comes first if it opens vertically. So because in this equation we have y squared first, we do know this is going to open vertically. It's going to open up and down. Because there is nothing with the y, we know our k value is 0. Since there's nothing with the x, we know our h value is 0. So our center is at 0, 0. Your a squared value always comes first, so we know that a squared is equal to 9, or a is equal to 3. Now this tells you how far you need to go to get to your two endpoints for your transverse axis. Now we know it's going to open vertically, so from here I'm going to go vertically up 1, 2, 3, I'm going to put a dot. I'm going to go down 1, 2, 3, I'm going to put a dot. My b value, or my b squared value, is 25, so b is equal to 5. Now this tells me the length of my conjugate axis. We know the conjugate axis is 2 times b, so if we start from the center, it's going to tell me horizontally I'm going to go 5 units to the left, and I'm going to go 5 units to the right. Now once I have those points, I can create a little box. And this box will help me create my asymptotes. Your asymptote should go from corner to corner, and it should go through the center. Remember, the asymptotes are the lines that your graph will approach but will never actually touch. Now the two values that are on the transverse axis are your vertices. That's where your graph will start. It will go towards your asymptotes but never touch it. And this will be the graph of our hyperbola. In this example, our center is going to be located at -1 and -2, because remember when you pull them out of the parentheses, you change the signs. Our a squared value is 9, so our a value is 3. The a is with the x value, so that means left to right. So we're going to go to the right 3 and put a dot. We're going to go to the left 3 and put a dot. Those are the two vertices we're going to graph from. Now our b squared value is 16, so b is equal to 4. So we go back to our center. We're going to go up 4, and we're going to go down 4. We can create our box that goes through those points. Now from our box, we can create our asymptotes. Remember, it goes through the center and goes through the vertices of the box. Then we're going to start at our vertices. Remember, the x value came first, so it's going to be the ones that are going to open horizontally, so it's going to go towards the asymptotes but never touch it, and towards the asymptotes but never touch it. Now this one is not in the correct form, so we do need to get the equation in the correct form first. So we're going to have to group our x's, group our y's, and take the constants to the other side if we have any. Now we are going to have to complete the square. Before we can complete the square, we do need to have the x squared by itself and the y squared by itself. So we are going to have to factor out the 25 for the x and the negative 16 for the y. Because we are factoring out a negative 16, positive 96 divided by negative 16 gives us a negative 6y. Now we're going to complete the square. Remember, when you're completing the square, you do the b over 2 squared. For the x's, our b value is 4, so 4 over 2 squared. 4 divided by 2 gives us 2. 2 squared gives us 4. So we're going to put a positive and a negative 4 in there. For our y values, our b value is negative 6. So we're going to put a positive and negative 9 into that equation. Now we do not need the negative ones inside there to have our perfect square trinomial, so we're going to factor those, or we're going to distribute so we can pull those out. (25) times the negative 4 gives us negative 100. Negative 16 times the negative 9 is going to give us a positive 144. Now we're going to take these constants and we're going to take them to the other side. Right now we have a positive 144, so if we subtract that over, 444 minus 144 is going to leave us with 300. We take that negative 100 over, so if we are going to add it to the other side, 300 plus 100 gives us 400. Now we can factor these. What multiplies to get 4, that adds to get 4, that's going to give us the 2. Multiplies to get 9, adds to get negative 6 is negative 3. And we did have 400 on this side. To be in the standard form of a hyperbola, we do need to have it equal to 1. So we are going to divide everything by 400. So our equation in standard form is going to be x plus 2 squared all over 16, because 25 goes into 400 16 times, minus y minus 3 squared over 25, because 16 goes into 400 25 times, is equal to 1. So when we go to graph this information, we define the center, the A, and the B. Our center is going to be located at a negative 2 and a positive 3, because remember, when you pull them out, you change the signs. So our center, negative 2, positive 3. Our A squared value is equal to 16. So our A is going to be 4. Since the A is with the X, we're going to go horizontally 4 units. To the left, this will be a vertice, and 4 to the right. And that will also be a vertice. The B squared value is 25, so B is equal to 5. So we go back to the center, we're going to go 5 up, and we're going to go 5 down. And then we're going to create our box. Remember, your asymptotes are going to start at the center and go through the vertices. When you graph, you're going to start at the vertices. You go towards the asymptotes. Now you can also be asked to write an equation of a hyperbola if they give you different characteristics. Remember, just like when we were dealing with an ellipse, to find the center, you do the midpoint formula. And it doesn't matter if you find the center of the vertices or the center of the foci, it would be the same. So -3 plus -3 over 2 and -6 plus 2 over 2 is going to give us a center located at -3 and -2. When you need to find your A values for the vertices, we know the distance between vertices is 2A. And we know that 2C is the distance between the foci. Again, this is the same as what it was for an ellipse. So if you notice on the vertices, the x's stay the same, so we just need to see how far apart the y's are. From -6 to +2 has a distance of 8, so then A would equal 4. On the foci, again, the x values stay the same, the y's are the ones that are changing, so a distance from -7 to +3 is 10. So C will equal 5. Now we need to find our B value. When we're dealing with a hyperbola, C squared is equal to A squared plus B squared, or 25 is equal to 16 plus B squared. To get the B by itself, we're going to subtract the 16 on both sides, and we're going to get that B squared is equal to 9. Now we need to go back and look at our equations of the standard form of a hyperbola to decide which one it's going to match. So the x values are staying the same. It's the y values that are changing. So this means this is going to open vertically. So our equation is going to be y minus k squared over a squared. So now we just need to take our values and substitute in for our equation. So we're going to have y plus 2 squared over 16 minus x plus 3 squared over 9 is equal to 1. On this one, they are giving us our vertices and the asymptotes, the equation for our asymptotes. Again, we are going to find the center first. So we're going to find the midpoint. So -3 plus 9 over 2 plus -9, and 0 plus 0 over 2. -3 plus -9 is -12. -12 divided by 2 gives us -6 and 0 as our h and our k. The distance between our vertices is our 2a value. So 2a from -3 to -9 is 6 units, or a is equal to 3. Now we need to look at the asymptotes. Because in our equation, or when we're looking at our vertices, the x values were changing and the y's were staying the same, we do know that our equation is going to be in the form of x minus h squared over a squared minus y minus k squared over b squared is equal to 1. But we also know that our asymptote is going to have a slope of plus or minus b over a. Now if we take a look at our asymptotes have the slope of plus or minus 2. So if our slope is 2 and our slope is b over a, we already know our a value is 3. We can solve for the value of b. So we can multiply both sides by 3, and we can get b has a value of 6. Now we have our h, k, a, and b values, so we can substitute them in and write our equation. So this is going to be x plus 6 squared, because remember when you put it in the parentheses, you change the sign, over a squared. A is 3, so we get 9. Because the k value is 0, you can just write this as y squared, or you can write in parentheses y minus 0 and then square it. Either answer is acceptable. We know our b value is 6, so b squared is 36 is equal to 1.